lesson is on scale drawings. Let's go over some vocabulary. You actually have a little bit of familiarity with this. Let's take a look first. Let's get to our third definition, the word scale. When we talk about scale, we're talking about the relationship between the dimensions of drawings and models to the actual object's dimensions. And those models are represented two different ways. First, in a drawing. A scale drawing is a two-dimensional drawing that is similar to the object that it represents. A model, a scale model, is a three-dimensional model that is similar to the object that it represents. Now, if you remember that word similar from last lesson, it means that the object's dimensions are proportional to the dimensions of both the drawing and the model. And scale is written in two different ways. One with a colon in the middle, where the first number is your scale measure, which is the smaller number, and then your actual measure follows the colon. And then down here you can see it can also be written as a fraction, where the scale measure, your smaller number again, will be your numerator, and your denominator is the actual measure. So now what we're going to do is we're going to solve three different problems, three different types of problems to help you understand this better. Let's take a look at our first one. It says that a map has a scale of 1 centimeter equaling 8 kilometers. What we want to know is what is the actual distance between two places that measure 5 centimeters apart on the map. It's actually not very difficult to figure out. The first thing we do is we start with an empty proportion. And you remember that is a fraction bar, an equal sign, and another fraction bar. And our first fraction in our proportion is going to be the scale that we're given. So remember, the number that comes first is our numerator. So we have 1 centimeter over 8 kilometers. And now what we do is we fill in any other numbers that we know. We know that on the map, the two places are 5 centimeters apart. Now, since centimeters is in the numerator in our first fraction, it absolutely has to be in the numerator of our second fraction. So I'll put the 5 centimeters here. And we are looking for the actual distance, so our denominator here is x kilometers. And if you remember from past lessons, our next step now is to cross multiply. So on the left we have 1 times x, and that equals 8 times 5. So we have 1x equals 40. So the distance between these two places is 40 kilometers. Very straightforward. Let's take a look at our second example. It's a little different from this one. Now in this example, we're being asked to find the scale of the drawing. I'll read the problem to you. In a scale drawing, a table is 3 inches long. Its actual length is 8 feet. Find the scale of the drawing. Now this is a little bit more complicated than the first example, so I wrote out some steps, and I'll go over them as we solve this one step at a time. The first thing we have to do is write the scale in fraction form. Our scale in this problem is 3 inches to 8 feet. So our drawing measurement is 3 inches, that's our numerator. 8 feet is our denominator. Now when we have to find the scale, what that means is our goal is to have a numerator of 1. And the first thing we have to do here, because we're working with inches and feet, is we have to convert the feet into inches. We need to be working with the same unit, and the rule of thumb is to change the larger into the smaller, and that's our second step. So our 3 inches in the numerator stays the same. Now, 8 feet. You remember that 1 foot has 12 inches in it, so 8 feet has 8 times that, which is 96 inches. Our third step is to simplify this fraction. Both the numerator and the denominator are divisible by 3. So 3 over 96 gets simplified to 1 over 32. And our last step, now that we have a numerator of 1, is to rewrite this scale using the colon. Our numerator comes first, so our scale for this problem is 1 to 32. And we have one more example to go over. This says that a blueprint scale for a house is 1 to 42. Find the actual length of a wall that is 3 inches long on the blueprint. Well, remember, we start with our empty proportion, and our first fraction is always going to be the scale. And we're told that the scale is 1 to 42. And this actually is not very difficult to solve. All we have to do now is figure out where this 3 inches belongs, and then we have to solve for the other piece. This 3 inches is on the blueprint. It is the first part of the scale. So we'll put our 3 inches up here. And we don't know how many inches that represents in the actual house. Our next step is we cross simplify. We have 1 times x equals 42 times 3. And we find that x equals 126 inches. So for this blueprint, when you see something that is 3 inches long, in real life, it's actually 126 inches in length.